Suppose the first one is the limit of a constant is constant. That means whatever the limit is, and whatever your limit is, that is x tends to a. And if a is a constant, that means there is no function of x in it. Therefore, its answer will be k only. If it is second one, if x tends to a, limit x tends to a, k times of fx. That means the constant will come in front and we will apply the limit x tends to a to fx. Third one, limit of sum or differences. If there are two functions fx and gx, and we have a plus or minus sign in between them, so we have to apply limit individually to the first one, that is limit x tends to a fx plus minus limit x tends to a gx. Similarly, if there are two functions in product, that means limit x tends to a fx into gx, then we have to apply limit in the first function, that is limit x tends to a fx into limit x tends to a gx. Similarly, if we have a function in the form of p by q form, that means fx at the numerator and gx at the denominator. That means at that moment your problem will be limit x tends to a fx divided by gx. That means we have to apply limit individually at the numerator as well as to the denominator. But we have to keep one thing in mind, that dx, that means your denominator should not be equal to 0. That is meaningless. We have now some standard results. Or
Excuse me, sir. Sorry.
yeah.
The material which you're using is not visible here. Is it gonna be audio only? No, any visible materials like to use the
The slide is not
books.
visible to you.
Yeah, it's not visible to me. Yes.
Okay, just a minute.
All right.
I will see to it.
The only thing I can see is you. It's your face
No, my
and
face
the
is.
bookshelf.
You can't see the slide. My question is that, is the slide visible now?
All right, now it's visible, sir.
And now,
The
yeah,
slide.
it's visible.
Now you
Sure.
can see the what I was telling. Now it's visible.
Yes.
I said something that there are five different properties in which the limits are applied, or the method by which limits are applied. Now the thing is that now we have some standard limits. If we have a problem in the specific form, in this specific form, that means whatever is there on the right side, that is in front of equal to sign, that will be its answer. Now we have limit x tends to a, x raised to the power n minus a raised to the power n upon x minus a. Its answer will be similar to n times of a raised to the power n minus 1. You don't be worried about it. I will be discussing the problems later after discussing these 5 points. Second one is limit x tends to 0, 1 plus x raised to the power 1 upon x. Its answer will be simply e, that is exponential. If we have limit x tends to 0, a raised to the power x minus 1 upon x, its answer will be log base e times a. If we have anything in the form of limit x tends to 0, e raised to the power x minus 1 upon x, its answer will be 1. If the fifth one is limit x tends to 0, log 1 plus x upon x, its answer will be 1. But these are the 5 standard results. We have to remember these results. Now we will see. I will show you how the problems related to limits are solved. Straight away, the problem is limit x tends to 1, 2x squared plus x minus 3 divided by x to the power 3 plus 9. Now, you can see that the above problem is in the form of fx divided by gx. As I told you, limit will be applied in the numerator as well as in the denominator. So I will be replacing x by 1. So that means 2 into 1 plus 1 minus 3, that is in the numerator. And upon the denominator, I am getting 1 plus 9. While solving the numerator, the answer is 0. And while solving the denominator, it is 10. So its answer will be 0. The second problem is we have something, as we can see, there are two functions in the form of multiplication. The first function is x squared plus 4, and the second one is 3x minus 2. So I will be applying limits individually to both, and I will be multiplying the answer. While applying the limit x tends to 1 to the first function, that will be 1 plus 4. And in the second, it will be 3 minus 2. 1 plus 4 is 5, and 3 minus 2 is 1. So 5 into 1 is 5. That means you will be getting this answer. These are the two basic types of problem. First one is in the division form, and the second one is in the multiplication form. Now, this is something we have to understand. The problem is evaluate limit x tends to 0 under root 1 plus x minus under root 1 minus x divided by x. First of all, what you are supposed to do, if you get anything in this form, that means either the numerator or the denominator is with under root. We have to rationalize the numerator. Now the question arises how this rationalization takes place. Rationalization is always done with a sign opposite to this sign. Nothing to do with this, nothing to do with this. We have to change this sign. That means I will be multiplying and dividing this function by under root 1 plus x plus under root 1 minus x. Mathematically, this is 1. But algebraically, it is in the numerator, it is a minus b into a plus b. A minus b into a plus b is equal to a squared minus b squared. That means I will be squaring this minus squaring this. So by square, this under root will be removed. While removing this, the numerator will be 1 plus x minus 1 plus x. We have to keep one thing in mind. We have to change the sign of these numbers because we have minus in front of this. That means it will be 1 plus x minus 1 plus x divided by x times the whole denominator. Now, this one and this one will get cancelled. We will be remaining with 2x. 2x divided by this. This x will be cancelled by this. So we are left with this. Now we will be applying limit. Limit x tends to 0. That means we will be replacing x by 0. So in numerator, we are going to get under root 1 plus 0 plus under root 1 minus 0. Under root of 1 is 1. 1 plus 1 is 2. 2 divided by 2 is 1. That means what we have learned, if we have under root either in the numerator or in the denominator, we have to multiply the whole numerator and denominator by a function which has opposite to this sign. Here we have minus, so we have taken plus. If this would have been plus, so we would have taken minus over and minus over here. Mathematically it is 1, but algebraically it will be converted into a formula. And the formula is a plus b into a minus b, which is equal to a square minus b square. The third problem is, if you see that in the limit section, it is x tends to infinity, and there is a numerator as well as a denominator. Now, what we will be doing? Find out a number. Find out the terms, or not the number, which has the maximum power. Here in the numerator, maximum power is x square, and in the denominator, it is x cube.
Excuse me, sir.
Yes, sir.
Are you gonna share this PowerPoint? Yeah.
Yeah, it will be in the video. Definitely, it will be in the video.
All right, all right.
And it is there in your study material also. I'm just discussing how to solve the problems to make you conversant how this can be evaluated. You are able to see the slides, correct?
Yeah, we're able to see they are visible here.
Now the thing is that we have to understand how the problems will be solved. I'm just discussing how the problems will be solved. Now here you see that limit x tends to infinity. Nothing to do with it. Just find out which term has the maximum power of the variable. Here we can see that it is x cubed in the denominator. So what I will be doing? I will be dividing numerator as well as denominator by x cubed. So here you can see it is 2x squared divided by x cubed will be 2 by x, plus 5x divided by x cubed, it will be 5 by x squared, plus 1 by x cubed. We will similarly move to denominator. 3x cubed divided by x cubed is 3, minus 2x divided by x cubed will be 2 by x squared, plus 4 divided by x cubed. Now we will be applying limits to every element. In this case, 1 by x is 0, 5 by x squared is 0, 1 plus 1 by x cube is 0. That means your numerator is 0. And in denominator, this is a constant number. That means it will remain as 3. And 1 by x squared is 0. 1 by x cube is 0. That means you are left with 0 by 3. And 0 by 3 is nothing but 0. I'm just repeating what is the method for solving if the limit is given in the form of x tends to infinity. You have to find out the variable which has the maximum power. In this particular problem, it is x cubed. That means first step is to divide numerator and denominator by x cubed. And then 1 by x is 0. So we will be replacing all the elements where we have either 1 by x, 1 by x squared, 1 by x cubed by 0. We will be left with a number 3. And 0 divided by 3 is 0. So this is the method how a problem related to x tends to infinity is solved. Now, second part, moving further in the limit and continuity session, we will be talking about continuity. Simply, what is meant by word continuous? Continuous has been transformed to continuous. Continuous means something which doesn't break. Correct? A function is said to be continuous if the graph of such function has no breaks. That is, if the graph can be drawn without lifting pen off the paper. The graph of a continuous and discontinuous functions are given below. You can see The first graph that is continuous, that means it's not breaking. And in the second one, it is simply a term like this, nothing else. This is continuous, and but this is a term. So that means this one is a continuous function, a graph of a continuous function, and this is a graph of a discontinuous function. Now, a function is continuous if minor changes in the independent variable generate minor changes in the functional value. Mathematically, a function f is said to be continuous at x is equal to c if number one, the function has the function is defined at x is equal to c. How this is defined? That limit x tends to a, fx is equal to fc. That is limit x tends to c negative, fx is equal to limit x tends to c plus, fx is equal to fc. In other words, we can see that, or we can say that limit of a function on the left side must be equal to limit of a function on the right side and must be equal to the value of the limit. You will see how what does this red phrase means. If fx is continuous for every value of x in its domain, it is said to be continuous throughout the interval. If a function which is not continuous at a point is said to have a discontinuity at that point. Third one, a function is continuous over an interval a comma b if it is continuous at every point within the interval. Then only you are going to get a graph something like this. Suppose this is a and this is b. If a graph is continuous between a and b, that means we can say that a function is continuous. And suppose a is here and b is here, and we get a graph over here. That is not a continuous graph. Now we see. We will examine a continuity of a function. The function is fx is equal to x minus a, and we have to check the continuity at x is equal to a. So straight away what we will be doing? We will be adding a constant function h to a. That means we will be substituting x by a plus h. If x tends to a, then x tends to 0. That means your this limit x tends to a fx will be equal to limit x tends to 0. X has been replaced by a plus h, and you are going to get, when h is 0, you are going to get a value of a. Correct? Now, if h tends to 0 and a plus h, limit h tends to 0, a plus h minus a, that means what is happening? This a will and this a will get cancelled. You will be left with h, and when you will be applying limit x tends to h, it will be 0. That means fa is equal to a minus a, that is 0. We can say that fa is equal to h tends to 0, function a plus h is 0. These two values are equal. That means we can say that the function is continuous at x is equal to a. What are the properties of continuity? Fx is equal to a constant. Constant number is continuous for all real numbers of x. If we have any function x raised to the power n, and n is a natural number, then the function will be continuous for all real numbers of x. If we have a polynomial function is continuous. If we have function fx and gx, then fx plus minus gx are limits and continuity. They are also continuous. That means sum or difference of two continuous function is continuous. Similarly, for multiplication, If two functions are continuous, then their product will be continuous function. If we have two functions in division form, fx by gx, if these two functions are continuous, their answer will be continuous, provided the denominator is not equal to 0. Similarly, what we see, we found that this is somewhat related to limits. This is what it was discussed in limits. Now, try to understand the concept of continuity. We have a function fx, which has three conditions in it. The first condition is x plus 1 if minus 1 is less than equal to x less than 0. Second condition is x if 0 is less than x less than equal to 1. And the third condition is 2 minus x if 1 is less than equal to x less than equal to 2. So what we are supposed to do? We have three functions. We have to check that the function is discontinuous at x is equal to 0, but it is continuous at x equal to 1. Straight away, we will be putting x is equal to 0. When we will be putting x equal to 0, that means now the thing is that in which function to prove its continuity, we will be talking about continuity first. In that continuity function, your left hand limit and the right hand limit must be equal to the value of the function. Here you have to see here where you are going to get x is equal to 0, which has that condition where x is 0. Here you can see for fx x, 0 is less than equal to x less than equal to 1. That means this is the function for limit x is equal to 0. So we will be putting f0 to x, it will be 0. Correct? That means your functional value at x is equal to 0 is 0. Now we will be moving to right hand limit and left hand limit. So here we are taking right hand limit because we are taking x tends to 0 plus. 0 plus is where? Here only. Again you are going to get 0, and where it is 0 negative. 0 negative is here on the left side of 0. That means we will be taking this function x plus 1. When we will be applying the limit x tends to 0 to x plus 1, we are going to get 1. Here what we see that limit x tends to 0 plus is not equal to limit x tends to 0 minus. If this condition has been reached, we can say that x is discontinuous or x is not continuous at x is equal to 0, because this, and this, all the three have to be equal. Now, in the second part, we will be showing that x is equal to 1. In that case, it is continuous. We have to take x is equal to 1. Your limit will remain the same. Your function will be same because you can see that fx is equal to x when x is equal to less than 1. Your fx will be 1, f1 will be 1. Now we will be taking limit x plus 1. In that case, we have to take 2 minus x. This function, your value is x plus. So in x plus, we will be taking this 2 minus x. We will be applying limit x tends to 1 in 2 minus 1. It will be 2 minus 1, which is equal to 1. Now we will be moving to fx tends to 1 minus. Where we are going to get f minus 1. Here we will be applying the limit x tends to 1. We are going to get 1. That means here we see that this value at f1 is 1, f x tends to 1 plus is 1 and fx tends to 1 minus is 1. That means here all the three conditions are satisfied. We can say that a function is continuous at x equal to 1. Now, we have a problem which is in the form of numerator and denominator. That means a problem with a rational expression. We have to find the points of discontinuity of the function. So straight away, when a problem is related to find the points of discontinuity of the function, first of all, you have to equate your denominator with z. A function will be discontinuous only when the denominator is 0. That means what we will be doing, we will be putting up this 12 plus 12x squared plus x minus 20 equal to 0. What we will be doing, we have to, this is quadratic function, we have to split the middle term. Now the question arises how this middle term will be split. We have to multiply this 12 by 20. Forget about the signs. We get 240. And we have to split this 240 in the form of those two numbers. When we subtract or we add, we get 1. So here when we multiply 16 into 50, we get 240. And when we subtract 15 from 16, we get 1. So we can split this term in this form. 12x squared plus 16x minus 15x minus 2 equal to 0. Please mute yourself. Now, we will take this 4x common from 12 and 16. So we will be getting 3x plus 4. And here we will be taking minus 5, 3x plus 4. We have to keep one thing in mind, that these two brackets should have the same value and the same numbers. Mr. Mubarak, please mute yourself. Now, we will be taking this 3x plus 4 common, and we will be left with 4x minus 5. We will be equating it to 0. So we are going to get x is equal to 5 by 4 and x is equal to minus 4 by 3. That means we can say that points x equal to 5 by 4 and minus 4 by 3 are the points of discontinuity. What is the how to find the points of discontinuity? We have to equate the denominator by 0. Now, we will be discussing a problem which has to be converted into a limit problem, and then its answer has to be solved. That means we can say that the application of limits in world problem. We have a problem that an electric company charges from its customer the following amount of service. The first one is rupees 5 for first 20 kilowatt hours or less. You can see 5 for x less than equal to 20. First condition is satisfied. Second one, 25 paisa per kilowatt hour for the next 80 kilowatt hours. That means 1 by 4 is 25 plus 25 by 100 into x minus 20. When we are moving from 20 to 100 units, that means the price of this 20 units will be included into it. That means your function becomes x plus 1 by 4 into x minus 20. And the condition is if x is less than 20, And if x is greater than 20 and less than 100. The third part is and 10 paisa per kg kilowatt for any hours above 100 kilometers. That means this amount will be included 25 plus x into x minus 100 by 10 for x greater than 100 for greater than 100 units. That means this problem has been converted into three conditions of cost. First one, second one, and third one. Now we move to what we are supposed to calculate. We have to express the cost function C as a function of x. This is what we have done. Now we have to test the continuity of C at x is equal to 20 and x is equal to 100. So first of all, what we will be taking? We will be taking x equal to 20. And your function is Cx is equal to 5 because it is x less than or equal to 20. That means your Cx will be 5. Now we will be taking left hand limit. That means less than 20. Where it is less than 20? Less than 20 is here only. That means your answer will be 5. Now we will be moving to right hand limit. That is x tends to 20 plus. Where is 20 plus? 20 plus is here in this function. When you apply limit x tends to 20 in this function, so this will be removed. We will be left with 5 only. Here what we see, Cx is 5, left hand limit is 5, and right hand limit is 5. That means we can say that this particular problem is continuous at x is equal to 20. Why? Value of the function, left hand limit, and right hand limit. All the three values have the same value of 5. Similarly, we can show that the function is continuous for 100 units also. Now, we move to unit 7. This is a very wide topic. It has application in so many ways, and there are different methods of solving a problem. The same thing is there. We have to identify the problem, what is the nature of the problem, and then we will apply how the problem will be solved. Now the question arises, what is meant by differentiation? Differentiation is basically the rate of change of one variable of function with respect to another on which it depends. This is called the derivation of the function. Differentiation is a process of finding out the derivative of a continuous function. Those functions which are derivable or those functions which are continuous are differentiable. A derivative is the limit of the ratio or the small increment in one variable of the function corresponding to a small increment in an argument. That means other variable as the later tends to 0. This rather we can say that it is the next step of continuity. Now, derivative. A derivative in calculus is the rate of change of quantity y with respect to another quantity x. It is also termed the differential coefficient of y with respect to x. Differentiation is a process of finding the derivative of a function. A derivative is the limit of the ratio of the small increment in one variable of the function corresponding to a small increment in the argument, that is the other variable, as the later tends to 0. These are the basic definition of the basic concept of derivative. Now, how it is represented. We have a function of y. in terms of x. So when we are differentiating it, we will be writing dy by dx. If in place of y we have fx, we will be writing f dash x, which is nothing, which is d fx divided by dx. Don't get confused by eliminating this x by this. D by dx is a single term. Now the question arises how we conclude or how we read or how we reach dy by dx. By definition, when we apply some small increment with y, and the small increment with y will be dy, where you can see that it is delta y, and in denominator we are saying that we have a small increment of delta x. Your fraction is in the form of delta y by delta x. You are applying limits delta x tends to 0. When you are doing this, what you are doing? Limit delta x tends to 0 in a function of delta y by delta x. That is equal to dy by dx. What is dy by dx? It is basically a slope. We have a point x1, y1 and the other point x2, y2. Now we can see that we have to find this slope. Slope is always calculated from the ground level. We can say that this much is the slope in terms of numerical numbers. Then dy by dx is equal to slope is equal to y2 minus y1 divided by x2 minus x. Your slope is y2 minus y1 divided by x2 minus x. What are the different methods or what are the different rules where we can solve a problem related to derivatives? First one is constant function rule. Second one is power function rule. Third one is linear function rule. Fourth one is sum for rule for sums and differences. That means plus minus one. Then comes your product rule. Then the quotient rule, and finally at the top it is chain rule. We will see how these are deployed. First of all, we will start with derivative by first principle. We have a standard format for this. A function y is equal to fx is given to you, and you have to find the derivative, or we can say that the function is derived. The function is defined in the interval a comma b. By the definition of differentiation, a function y is equal to fx is there, and it is said to be differentiable at x is equal to c if limit x tends to 0 f c plus h minus fc divided by h exists, and the limit is called the derivative of the function fx at x is equal to c, or it is denoted by dy by dx, f dash x, or y1c. These are the different notations for showing the derivative. First one is dy by dx, second one is f dash x, and the third one is y1c. What are the different steps while we have to calculate the first differentiation or derivative by first principle? You have a function fx. First of all, you have to write y is equal to fx and mark it as equation number 1. Then, in second step, we will be adding a small increment in x and y. That means we will be adding delta x to x and delta y to y. Going back to step number 1, you see that you have y is equal to fx. So what we will be doing? Y plus delta y equal to f function x plus delta x. In the third step, we will be subtracting 1 from 2. That means y plus delta y minus y on the left hand side, and on the right hand side we will be having fx plus delta x minus fx. We are left with delta y is equal to f x plus delta x minus fx. Now we will be dividing both sides by delta x. On the left hand side it will be delta y by delta x, and on the right hand side it will be f x plus delta x minus fx divided by delta x. Lastly, we will be applying the limit delta x tends to 0 in step number 4. So on the left hand side we will be getting limit delta x tends to 0, delta x delta y by delta x equal to limit x tends to 0 fx plus delta x minus fx upon delta x. That means this is the actual derivative of the function fx at a comma b. Here you got it. The expression on the left hand side represents the derivative, which is instantaneous rate of change of the dependent variable corresponding to a change in the independent variable. The function is differentiable only if the limit exists, and the function must be continuous at that point. Normally, algebraic function, trigonometric function, exponential functions, inverse functions, trigonometric functions, they are all differentiable. Now, we will be applying the first principle to this function. The function is y is equal to x squared. If you remember, we were asked to add small increment delta x and delta y on both sides. So y will be y plus delta y is equal to x plus delta x whole square. Now we will be opening y plus delta y as it is equal to a plus b whole square is a square plus 2ab plus b square. So we will be left with, now we will be subtracting equation number 1 by 2. So on the left hand side we will be left with delta y, and on the right side we will be having delta x 2x delta x plus delta x squared. Now we will be dividing both sides by delta y delta x, so it will be delta y divided by delta x equal to 2x plus delta x 2x delta x plus delta x whole square divided by delta x. You will be left with 2x plus delta x. Now you will be applying the limit delta x tends to 0. So what will happen? This will be 0. You don't have anything with delta x over here. So you will be left simply with, so we can say that, yes, Mr. Mubamba.
Sorry, would you kindly explain again on the multiplication of delta x squared, delta x, sorry, plus the 2 squared, plus the squared, sorry.
You want this x plus delta x. This is
Yes,
nothing
on
but
the second part. Yes, on that same one. Thank you.
uh, 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 see to it. What is the step number 2? Increase x by small quantity delta x. That means I will be replacing this, or I will be adding x delta x to this function on the x side and delta y on the y side. Now you can see y plus delta y is equal to x function x plus delta x. So here what I did, I added delta y to this, and I added delta x to x. So this becomes x plus delta x power 2. Now, I have to apply a plus b whole square. A plus b whole square is a square plus 2ab plus b square. A square is x square. 2ab is 2 times of a. 2x plus delta, 2x into x, delta x, plus b square, that is delta x ka whole square. Here, to get this, I will be subtracting this from this. So I will be left with delta y. This and this will get cancelled and this will be left. Here you can see it is. In the next step, I will be dividing delta y by delta x. That means I will be dividing both sides by delta x. So here on left hand side, I will get delta y by delta x. And on the right hand side, I will get 2x plus delta x. When I will be applying the limit, delta x tends to 0. So this will be 0. There is no term including delta x in it. That means limit does not apply over here. So I will be left with 2x. Or in other words, I can say that the derivative of x square is 2x. Now, rules for differentiation. Derivative of a constant is 0. Suppose I have fx equal to 5 and I want to differentiate it. There is no term including of x in it. That means it is a constant and the derivative of a constant is 0. Second rule is x raised to the power n. Its derivative will be nx raised to the power n minus 1. Suppose we have fx equal to x power 7. By applying the rule, 7 will come in front of x and I will be subtracting 1 to the power. That means it becomes 7x raised to the power 6. Here you can see I have a function 3x raised to the power 8. 3 is a constant function. It will come in front. I have to differentiate x raised to the power 8. X raised to the power 8 will be differentiated by x. 8 will come in front of x and I will be reducing power by 1. So that means reducing 8 by 1 is 7 and bringing this 8 in front of x. That means the derivative of x raised to the power 8 is 8x raised to the power 7. Now I will be multiplying this. This becomes 24 x raised to the power 7. Now, fourth one, we have to differentiate these two functions and I have a plus minus sign in between. Mathematically, what I have to do? I have to differentiate fx, then add plus minus, or then I have to differentiate gx. This is what your theory says. Now, these are the two functions given to us. Fx is equal to 7 plus x to the power 12. You can see that x is a constant. That means its derivative will be 3. This is an algebraic expression of power 12. Its derivative will be 12x raised to the power 12 minus 1, which is 11. That means derivative of x raised to the power 12 is 12x raised to the power 11. Now, different problems to see. The first problem is gx equal to cube root of x. Cube root of x means x raised to the power 1 by 3. Here, power is in fraction form. We know that when we differentiate anything in the form of x raised to the power n, n comes in front of x and we have to reduce this n by 1. Here n is 1 by 3. So derivative of x raised to the power 1 by 3 will be 1 by 3 into x raised to the power 1 by 3 minus 1. That is 1 by 3 into x raised to the power minus 2 by 3. We don't have to keep minus power in the numerator, So we will be bringing it down. That means it will be 1 by 3 x raised to the power 2 by 3. You can leave your answer over here. Now you have a function y is equal to 1 upon x squared. Nothing to worry. Bring this x squared to the numerator. When a value is brought to the numerator, it is multiplied by a sign of minus 1 to this power. So x2, when coming up, will become x minus 2. How to differentiate this? I will be bringing this minus 2 in front of x, and I will be reducing its power by 1. You can see over here, minus 2 into x to the power minus 2 minus 1. This is minus 3. That means this is minus 2 raised to minus 2 into x raised to the power minus 3. We can bring this x raised to the power minus 3 to the denominator. So it will be minus 2 divided by x. The third problem. It is the fifth power of x squared. Mathematically, it is x raised to the power 2 by 5. I have to differentiate x raised to the power 2 by 5. So I will be bringing this 2 by 5 in front of x, and I will be reducing the power by 1. So I will be getting 2 by 5 times x raised to the power minus 3 by 5. Coming down, bring it down. This will be the power, and then make this power 5 at the cube root of 5. This is the third method, or third type of problem of solving the derivatives. Another problem. Now here you have 1 upon x. That means 2 into 1 upon x. You will be bringing this 2 in front, and your functional value is 1 by x. 1 by x means x is to the power minus 1. Now, you will bring this minus 1 in front of x, and you will be reducing minus 1 by minus 1. That means minus 1 is minus 2. So your problem becomes minus 2 times of x minus 2. Bring this minus 2 down to minus 2 upon x squared. Second type of problem is ft is equal to 4t cubed by 5 plus 3t squared. When you are going to differentiate, this ft will be transformed to f dash t. And on the right hand side, multiply this 3 by 4. It will be 12 t square, reduce the power by 1 by 5. You see, 12p square by 5 plus, bring this, multiply 3 by 2, 6, and reduce power 2 by 1. So it will be 60. That means you can see your answer over here. 12p square by 5 plus 60. The third problem is 2 x raised to the power 1 by 2. Bring this 1 by 2 in front of x and reduce the power of 1 by 2 by minus 1. When you will be reducing power 1 by 2 by minus 1, you will be getting minus 1 by 2. That means bring this minus 1 by 2 in the denominator. It will become 1 by 2. That means anything power 1 by 2 is under root of x. And further transforming it, you will get under root x divided by x. Now, try to understand what I am going to tell you right now. Here you can see that this is product rule. Product rule means two functions will be in the form of product. Suppose we take two functions at u and v. So how to differentiate it? When we are multiplying two functions in product, we apply product rule. Now the question arises, what is meant by product rule? In product rule, you can see that there is a problem given to you. Fx equal to x cube plus 2x plus 5 times 3x power 7 minus 8x square plus 1. Now, how to solve this big fraction? We have two things in product. That is your first u. U is this x cube plus 2x plus 5 and v is 3x7 minus 8x square plus 1. What we will be doing, what is the method? Keep first function as it is. Differentiate the second one. Plus keep this function as it is. And now differentiate function 1. So while we will be differentiating second function, that is 3x raised to the power 7 minus 8x square plus 1. So what we are going to get? Straight away see to it. Multiply this 7 into 3, 21, and reduce power 1. It will be 21 x raised to the power 6 minus sign. Multiply this 8 by 2 and reduce 2 by 1. That means you will be left with 16x. That means first part has been solved. Now plus sign, second derivative. The same function which is given in the problem. 3x power 7 minus 8x square plus 1 into d by dx of first function. What we have in first function? We have we have x cube plus 2x plus 5. That means its derivative will be 3x square plus 2. Multiply it and write the answer. That means it's when the function was given as fx, its derivative will be denoted by f dash x. Now, here you can see another problem which is in the form of u and v, because your first function is under root t and second function is b plus a plus b. So when we are differentiating by applying product rule, we keep first function as it is and we differentiate the second one plus what we have differentiated. It will come right now and it will be multiplied by the derivative of the first one. Here on the left hand side we will get f dash t. Moving further, we will keep root t as it is. We will be differentiating a plus bt plus a plus bt into differentiation of under root t. This is basically your correct chain rule, which is employed in bread industry. Now, you can see over here, we have to differentiate this function in terms of t. We don't have anything over here in terms of t. It will be 0. Differentiation of t with respect to t is 1. So you will be left with b only. Plus, bring this over down and this is t power 1 by 2. So while we will be differentiating it, we will be getting 1 by 2 log when we will differentiating this, so this will be 1 by 2 t raised to the power 1 by 2 minus 1. That means it will be minus 1 by 2. If this is the function by what we are left, we will be multiplying. P root 2 will remain as it is. Now we will be multiplying this term with this. After solving, we are going to get 2 under root t in the denominator. We will be multiplying this and we will be solving the numerator. By the numerator, we will get a plus 3bt. upon 2 root 2. Remember, root t into root t is t only. Root t into root t is t only. T into t is t square. Now we see another type of problem in which logarithmic function is used. Now the question arises how logarithmic subject is solved. We will take first function as x square and the second function as log x plus 7. On the left hand side we have y. So while differentiating we will be getting dy by dx is equal to first function as it is, differentiation of second function plus second function as it is, differentiation of first function. Now the thing is that one thing has to be kept in mind. Derivative of log x. Derivative of log x is 1 by x. You have to keep it in mind. Here we have log 3x plus 1. Straightaway what we will be doing? We will be writing it upon 3x plus 7 into derivative of log 3x plus 7. Derivative of log 3 plus x7 is 1 by x into derivative of 3x plus 7. The derivative of 3x plus 7 will be 3 only, and the derivative of 3x log 3x plus 7 will be 2x. Now we will be multiplying all these to simplify it. In the first function, we are going to get 3 into 1 is 3, 3 into x square is 3x square upon 3x plus 7. And in the second part, we will bring this 2x in front. So it will be 2x into log 3x plus 7. This is the derivative of the function. Now, we move to second important part. That is quotient rule problem. You are given a problem y is equal to x cube minus x square plus 1 divided by x square plus 1. What is the formula for solving this? If you have this, see it very carefully. d by dx of u by v. Straight away draw a line. Whatever is in the denominator should be squared. What has been squared will be moved to numerator, and we will be multiplying this with derivative of the numerator minus second function into derivative of your u is x cube minus x square plus 1 and your v is x square plus 1. Straight away what we are doing? Squaring. Because in formula it is square. Whatever has been squared has to be brought back to the numerator. It will be du by dx minus second function into derivative of first. So here we have numerator upon denominator. Another problem related to quotient rule. Quotient rule is square of the denominator, and in the numerator we are getting u derivative of u into v plus or minus u times derivative of v. Here we can see that we have this problem. So we will be squaring this in the numerator, then taking this the same function at the top, differentiating whatever is in the numerator minus what has been differentiated right now has to be written in over here, and it has to be different denominator and divided by denominator's quotient. We don't want to open, we will try to open the numerator. Derivative of x square will be 2x, derivative of x will be 1, and derivative of constant number will be 0. That is why you are left with 2x plus 1. When you will be differentiating x cube, power 3 will come in front of x, and you will be reducing 1 power by 1. That means derivative of x cube will be 3x squared, and the derivative of constant will be 0. Simply multiply it and simplify it. Another problem related to u by e. The formula is square the denominator, and in the numerator, whatever has been squared should be taken individually into derivative of the numerator minus denominator into derivative of numerator. Derivative of x square is 2x, and derivative of 2x is 2. Derivative of x is 1, and derivative of all constant is 3. Now comes the chain rule. What happens? You know that derivative of x is 1. Many a times we don't take it as, because many a times we don't take is that 1. That 1 comes due to this chain rule only. Suppose we have a function fx is equal to 3 times fx. There are two things on the right hand side. So first of all, what we will be doing, we will be differentiating hx. Differentiating hx will be h dash x. And when we will be differentiating g of x, so it will be g dash fx into f dash x. Suppose this chain rule has to be applied to a composite function, or we can say that to another concept type problem. We have y is equal to hx, and this y is equal to gu, where u is fx. So what we will be doing? We have to calculate dy by dx. Here you can see that you have function of u and x and y. All the three are there. That means mathematically one has to be eliminated. What I will be doing? I will be doing dy by du into du by dx. Mathematically, they will all cancel. Now see, comes the chain rule. There are many three types of problems which have been discussed over here. Now you have to be very careful and see to it how this has been performed. If we have to apply chain rule in y is equal to hx is equal to du, where q is a function of fx, then dy by dx is equal to dy dx of dy by dx is equal to dy by du into du by dx, which is written at the top over here. Now we take a problem. This problem is in the form of u by me. What I will be doing, you can see that these two powers are same. What I will be doing, I will be just considering this 2x plus 5 divided by fx minus 7 as u. So mathematically, what my problem will be now, y is equal to u power 4. So I can differentiate this y is equal to u4 as first function and u is equal to 2x plus 5 divided by 5x minus 1 as the second one. That means when I will be applying chain rule, the dy by dx will be equal to dy by du into du by dx. Now your question arises, how we will find out dy by du? Where is dy? And where is y and u? Y and u are here only in this type. So y derivative will be dy by du and u power 4 will be 4 u power 3. Here you got 4 power u3. Now second one is, where is this du by dx? Du by dx is here. You can see that it is in the form of u by v. So I have to apply quotient rule in it. What does the quotient rule say? Square this term, done. Take this term at the top taken and differentiate in the numerator. Derivative of 2x plus 5 will be 2. That is why we are getting 2 over here. Minus the numerator. Numerator is 2x plus 5 into derivative of 5x minus 7. Derivative of 5x minus 7 will be multiply these two and simplify. We get this. Now you were supposed to calculate dy by dx. Dy by dx was dy by du into du by dx. So multiplying these two terms, you will be getting dy by dx is equal to this term. Now you can see how chain rule is applied. We have to differentiate x till we reduce the power of x to 1. Another case for power limit. We have hx is equal to fx raised to the power n, and n is a real number. Technically, what we do, we bring this n in front of fx, and then we differentiate, we reduce one power, and then we differentiate f distance. Similarly, you can see that your function is fx equal to under root 3x square plus 4x. First of all, I will be transforming this into 3x plus 4 power 1 by 2. Now I will be different. So on the left hand side, fx will be changed to f dash x, and in the right hand side, I will bring this 1 by 2 in front of it. I will be reducing this 1 by 2 by 1, and I will be differentiating this again. When I will be differentiating this, I will get 6x plus 4. Here it is. Then I will be retransforming this, because under root is 1 by 2, and here we have minus 1 by 2. So I will be bringing this 1 by 2 at the bottom. And in the numerator form, we have 6x plus 4. So I can take 2 common from it. So I will be left with 3x plus 2 divided by under root 3x square plus 4. See another problem. You have y is equal to u raised to the power 5 by 2, where u is equal to 7 times 8, 7 times x8 plus 3x. What we will be doing, I have to calculate dy by dx. So here in my case, dy by dx will be equal to dy by du into du by dx. So for calculating dy by dx, dy by du, so what I will be doing, I will be bringing this 5 by 2 in front of it, and I will be reducing 1 to it. So I will be getting, and while differentiating this du by dx, so I will be multiplying this 5 into 8, that is 7. 8 7 is 56, and I will be reducing power 1. I will be left with power 7 plus 3 into 2 and reducing power 1. So I will be left with 3x. Now I will be putting all these values Now you see that you have a constant function over here, you have u over there, and you have x. In maximum part, x is there, so I will be transforming this equation to power x. That means I will be replacing the value of u by x. My u is 7x to the power 8 plus 3x squared. I will be just putting it over here, nothing else, recombining and closing. Now, some standard limits. Derivative of log x is 1 by x. Derivative of ex is ex. And derivative of a raised to the power x is a raised to the power x log base e power a. These are the standard limits. You have a problem like this. Y is equal to log 5x squared plus 7. There are two methods for solving it. I will be using the easiest one. As I told you, log x, its derivative is 1 by x. And we have to find the derivative of x again. Normally it is 1, so I will be applying this over here. What I did, dy by dx, I'm solving it by the first way. Dy by dx is equal to 1 upon this into derivative of x squared plus 7. I will be getting, I will be differentiating this. Differentiating 5x squared will give me 10x. And the derivative of constant is 0. So my numerator will be 10x. 10x divided by fx plus 7. This is the easiest method to solve this problem. Second one is e raised to the power 5x squared plus 4x plus 8. Straight away what we do, anything which is in the form of e raised to the power x has to be written, its derivative has to be written in that form only, and we have to differentiate it again. The power. Derivative of e raised to the power x will remain be e raised to the power x into derivative of x. So here you see that this whole is in the form of x. So I have to differentiate this. Add this power. 10x plus 4 plus 0. You are going to get. Now we have to apply product rule. You can see there are two things. First one is x squared and the second one is log 3x plus 7. That means there are two terms in it. What is the differentiation method for product rule? First function as it is, derivative of second function plus second function as it is, derivative of first function. We have first function is x squared and the second function is log 3x plus 7. What we will do? We will be writing first term as it is. We will be differentiating log 7x, log 3x plus 7 plus log 3x plus 7 into derivative of x squared. While solving this, x squared will remain here. This is log x. Derivative of log x is 1 by x into derivative of what you get down at that time when you are coming down. That means it will be x squared into 1 upon 3x plus 7 into 3. Derivative of 3x is 3. This function will come as it is and derivative of x squared is 2x. We are left with 3x squared upon 3x plus 7 plus 2x log 3x plus 7. Now, derivative of what I did over here right now, derivative of exponential and logarithmic functions. We have to calculate d by dx of EU. In that case, It will be EU into derivative of du by dx. Suppose we have a function in the form of a raised to the power n. In that case, what we will be doing, its answer will be a raised to the power n log n a into du by dx. Now you see the third one is d by dx of ln u. Ln u is 1 by u into du by dx. Then comes d by dx of log base e u. In that case, it will be 1 upon u log a into du by d. These are all the four standard results by which exponential and logarithmic functions are solved. On the right hand side of the screen, you can see the power rule. Power rule is that is what I was doing. X is to the power n. I was just bringing n in front of x, and I was reducing the power of n. This is power. In the column table form, you have standard results. A fx is a times of f dash x. Ux plus vx is u dash x plus v dash x. Fu is f dash u into du by dx. Constant derivative is 0. X raised to the power n is x raised to the power n into x raised to the power n minus 1. If you have u raised to the power n, then n u raised to the power n minus 1 into du by dx. For product rule, if there are two things, first function as it is, derivative of second function, plus second function as it is, derivative of the first. U by v form is if square the denominator, bring that square in the numerator and multiply by the derivative of the numerator. Minus, it's not plus, minus. Minus u second function or the denominator or the numerator into derivative of the denominator. Derivative of e raised to the power x is e raised to the power x. E raised to the power u, if the problem is in the form of e raised to the power u, it will be e raised to the power u into du by dx. Derivative of log x is 1 by x. And the derivative of a raised to the power n is a raised to the power n log a. Now, we will be starting with implicit function. Implicit, if you remember, well, when we started differentiation, we said we will be talking about one term only. That means whatever we have seen just now, all the functions were having either u or x in it. If we have a function with x and y both at a time on the one side, that function is known as implicit function. Straight away in mathematical form, you can see that given a relation fx comma y equal to 0. That means a function which consists of x and y both. If it is not possible to express y in terms of x or y, then the relation is called an implicit function. To determine dy by dx in such an equation, we differentiate both sides of the equation and obtain an expression of dy by dx from the resulting equation. That means we will be transforming all dy by di times on the left hand side and bringing all x terms on the right hand side. Here, see the problem very carefully what I said just right now. You have a function over here where you can see that on the left hand side we have x cube plus y cube, and on the right hand side I can see a function xy. A function which has x and y together is an implicit function. Now, how to solve this problem? Nothing to worry. I will be applying that rule only. We have x raised to the power, what we said, power rule. X raised to the power 3. I will be differentiating this x power 3 plus differentiate y cube is equal to dy dx of xy. Now, reduce this power, bring this 3 in front and reduce the power, 3x square. Bring this 3 in front, reduce the power, dy. We get 3y square, but keep one thing in mind. While you are solving y cube, it will be, its derivative will be 3y square times dy by dx. Wherever you are getting y, you have to differentiate it, then you have to multiply it by dy by dx. On the right hand side, see to it. We have two functions in product. First function as it is, derivative of y in terms of x is dy by dx, plus second function as it is, derivative of x. Derivative of x is 1, so we will be left with y over. Now, simplify it, open it, bring all dy by dx on same side. So what I will be doing, I will be bringing this over here and I will be taking this over there. So this will be 3y square dy by dx minus x dy by dx equal to y minus 3x square. Here. Take this dy by dx common. You will be left with 3y square minus x equal to y minus 3x square. Common and bring it down. So dy by dx will be y minus x square upon 3y square minus x. This is the derivative for implicit function. We have to be very careful while solving implicit functions because they will be having x and y together. Here comes another form of problem. This is x under root 1 plus y times under root 1 plus x. You can see that, first of all, see to it that it has y and x together. While solving this up, what we will be seeing that this is not a problem related to implicit function. What I will be doing, I will be taking this y plus under root 1 plus x on the right hand side. When I will be taking on the right hand side, its sign will change. In the left hand side, it has plus. When it is taken down to right hand side, its sign, this plus sign will be changed to y. Straight away, I will be getting x under root 1 plus y equal to minus y under root 1 plus x. Square it. Square both sides. X square, y square, this under root will be lost. Minus is equal to minus y whole square is y square. Again, 1 plus x. So now that means you are left with x square into 1 plus y is equal to y square into 1 plus x. Open it up. X square plus x square y equal to y square plus y square x. Now, see to it, bring minus y square plus x square y minus y square x. Simplify x square minus y square. X square minus y square can be written as x minus y into x plus y. And similarly on the other two, we can take x and y common. By taking x and y common, we are left with x minus y. In the whole fraction, I will be taking x minus y common. So I will be left with x plus y plus xy equal to 0. This means either this will be 0 or this will be 0. Y cannot be equal to x. That means this will be equal. Now I will be differentiating. When I will be differentiating this, x derivative of x will be 1. Derivative of y will be dy by dx. And derivative of this will be x into dy by dx plus y. Or you can do one thing. Another method is dy by dx is equal to d by dx of x upon 1 plus x. What I've done, I've taken this y common. Y common ले लिया, बाकी सब कुछ इधर आ जाएगा, ये इधर आएगा, ये नीचे आएगा. I will be left with minus x upon 1 plus x. When I will be differentiating it, what I will be doing, I will be squaring this. Squared. I will take this at the top. I will be differentiating x. Derivative of x is 1. Minus x into derivative of 1 plus x. That means 1 plus x is derivative of 1 is 0 and derivative of x is 1. We are left with 1. In numerator, you can see we are going to get 1 only. And in the denominator, it is 1 plus x whole. Second one is ax square plus 2hx ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Now, x and y together. And this is a composite form of function. We have to differentiate. We will be differentiating both sides with respect to x. When we will be differentiating ax square, a is a constant, a will come in front, and we will be differentiating x square by. Then we will be taking 2x common, and we will be differentiating xy together. Then y, differentiating y square, 2g is common, differentiating x, 2f is common, differentiating y, and differentiating constant. When we will be differentiating x square, we will be getting 2x. So it products with a will be 2ax, 2g. This is a composite function. Composite in the sense it has x and y together. What we will be doing? We will be applying product rule in this. First function as it is, derivative of second function plus second function as it is, derivative of first. The derivative of x is 1. This is the derivative. Now, differentiating of y square. I told you when you will be differentiating y square or you will be differentiating any term with y, you have to differentiate normally and you have to multiply by dy by dx. So what I'm doing, I'm just bringing this 2 in front of it and I will be left with 2y, then multiplying by dy by dx. So it will be 2yb dy by dx. Derivative of x is 1, so I will be left with 2g. 2f dy by dx, I can't do anything, nothing has to be done in it. And derivative of constant is 0, and this 0 will remain as it is. Now what I will do, I will be just simplifying these. Simplifying this, taking dy by dx together. I will be getting dy by dx over here, here, and here. Plus 2by plus 2f into dy by dx plus 2ax to hy and 2g. I will be taking this on the right hand side because I want dy by dx. Then for dy by dx, I will be bringing this down. Here in the numerator, I can see that there is 2 in every function, every element of R. Easier to understand because we have x and y. These type of function where we have x and y together. are known as implicit functions. They have to be solved, and they will be solved in the same way what we do it. But when we get y, and when we differentiate y, we have to multiply that thing has to be kept in mind. Now, there is another method of calculating terms where powers are too big or the power. In that case, we have to apply law. Now, how that is? The method of logarithmic differentiation is used to differentiate functions of the form. You can see a composite function y is equal to fx raised to the power of gx. Gx is not a number. Here earlier we have seen that the powers were a number. Either 2, 3, 4, 5, 6 will be doing. The first step is to take log on both sides. Log on both sides means log of y, v of x raised to the power x, m raised to the power n. So we will bring m in front log. So we will see the properties. Here you can see if log is applied to two products, two functions which are in product. That means it is equal to log m plus log n. If it is in the division form, it is log m minus log n. And here, if it is in this form, m raised to the power n, so n will come in front of log n. Here, I did the same thing. I brought this gx in front of this, and then I wrote everything.
Is the class still continuing?
I thought it was actually my network.
I think he has just lost the connection.
Okay.
The class is still on.
Hey guys, the lecture is being concluded.
You are not audible, sir.
Is the screen visible to you?
Sir, we don't see.
No,
There is no
no, it's
screen
not
displaying.
visible.
It's not visible.
Yes.
Yeah, it's not visible.
Now it is visible.
No, sir.
Yes, sir.
Somebody is saying
Sir,
yes, sir. Somebody is saying no, sir. How is that
sir,
possible?
no, sir. No any screen displaying. Only your video is displaying. My body. The lecture note is not displaying.
This is not visible to you.
Sir, anyway, some about.
The screen, the
Yeah, it is
slide is not
displaying, sir.
visible to you.
Yeah, it is it is visible, sir. Now I can see it.
I was telling that how to differentiate a function when it is in the form of y is equal to x raised to the power x. Here, the thing is that x is not a number, the power one. This power is not a number. So in that case, we have to apply log. Applying log on both sides means log y is equal to log x power x. Log power x. In that case, I have to apply this log m raised to the power n. I will be bringing this n over here and log m, multiplying it with log n. So I have just brought this x over here and multiplying it by log x. Now this is a linear function. I can differentiate it now. As I told you earlier also, that whenever you are differentiating any term with y, you have to differentiate normally, and you have to multiply it by dy by dx. I know that log x, derivative of log x is 1 by x. Derivative of log y is 1 by y dy by dx. Moving on the right hand side, I can see that there are two functions, x and log x. The first function will be x and the second function will be log x. By the rule, first function as it is derivative of second function plus second function as it is derivative of the first function. On the left hand side, it will remain the same. And on the right hand side, derivative of log x is 1 by x. So I will be multiplying x by 1 by x plus log x into derivative of x is 1. That means I will be left with 1 plus log x. Here, dy by dx, I will be bringing this y over here. So it will be dy by dx is equal to y times x plus log x. You can see that this y is nothing but x raised to the power x. So I will be changing dy by dx is equal to x power x into 1 plus log x. This is the answer. I'm just repeating, when the powers cannot be reduced, simply when the powers cannot be reduced, or in other words, the powers are not numbers. In that case, you have to apply log. See, x raised to the power y is equal to y raised to the power x. Again, you see that on the power form, there is on the left hand side it is y, on the right hand side it is x. These are not numbers. So straight away I will be applying log on both sides. That means log x raised to the power y is equal to log y raised to the power x. I will property. I will be bringing this y in front of log x and this x in front of log y. This will be y log x is equal to x log y. You can see that here again there are two functions. First function is y and the second function is log x. This is on the left hand side. And on the right hand side again, we have two functions x and log y. I will start differentiating both the sides simultaneously. First function is y, first function as it is derivative of log x plus log x into derivative of first function is equal to first function as it is derivative of log y plus log y as it is, derivative of first function. Derivative of log x is 1 by x, y into 1 by x. Derivative of y is dy by dx. This will be log x dy by dx is equal to derivative of log y is, I told you derivative of log y is 1 by y into dy by dx. Here comes. Plus log y into derivative of x is 1. So I'm left with this. I will be just combining these. That means I will be taking these dy by dx on left hand side, and I will be bringing this on the right hand side. So it will be log x dy by dx minus x dy by dx upon y dx equal to log y minus y by x. Taking dy by dx common, I will be getting log x minus x by y equal to log y minus y by x. I want dy by dx, so I will be bringing this down. While bringing down, so I will be getting dy by dx is equal to x log y minus y upon y log x minus x into y by x. This is how differentiation of composite functions are done when the powers cannot be reduced. Another composite form of how the differentiation can be done. Straight away looking at the problem, you can see that this is something, it has numbers, and it is in the form of x by y. That means a rational. I will be doing. I cannot apply quotient rule in this problem method. I will be applying log on both sides. Log y is equal to log of this. You can see that this is in numerator and denominator form. So what I will be doing, log m by n. Log m by n is equal to log m minus log n. So it will be log y. Now you can see that there are three functions which are in the multiplication form. So they can be split up by adding plus sign. So that means log x plus 1 power 10 plus log x plus 5 plus log x plus 6 minus, because this is in the denominator, minus log x plus 7 power 2. Now you can see that here it is a linear power, here it is a linear power, but here it is power 10 and power 2. I will be applying this property in this. I will be bringing this 10 over in front, and log x plus 1 plus these two will remain the same, and this 2 will come in front of this. Now everything is in the linear form or in the addition or subtraction form. I will be differentiating log y is 1 by y into dy by dx equal to 10 as it is. Log x plus 1 is 1 by x plus 1. Log x plus 5 is 1 by x plus 5. Log x plus 6 is 1 by x plus 6. Minus 2. Log x plus the derivative of log x plus 1, x plus 7 is minus 2 upon x plus 7. What I have done, I will just write these numbers. Y over here and this. I will be replacing this y by function. This composite function has been solved in 5 or 6 lines by applying logarithmic tools. Any question from anyone? Am I audible to you?
Yeah, you're audible. But the screen has disappeared. We cannot see on the screen.
Sorry. I can't get you. What you said?
You're audible. We can hear you. But the screen has disappeared. So we have lost the visual.
No, I'm not right now. I'm not sharing any screen with you. I'm just asking you what has been not was it were you comfortable in understanding it? Because I will be continuing this topic in the next session also, but you have to work of your own also try to understand the concept. I will be discussing the concept once again in the next session, but in the meantime, you just go through your study material also.
Okay, I get it. Yeah, some of the points which have been presented we understood,
You just go through
but
the
then I think
material,
we
and if you find
need to
something
go.
difficult, you can ask me in the next session. Definitely, I will
All right,
respond to it.
all right. We'll come back to you when we have a question.
Yeah. Anyone else? Should we conclude today's session?
Yes, we can conclude.
Okay, thank you. Bye bye. See you next week. I will be continuing with this different teacher.
Thank you so much.
Thank you. When we find some questions, then we'll ask next week.
Okay, fine.
Yeah.
Thank you. Bye bye.
All right, bye. Thank you so much.
Bye.